Hello everyone, my name is Angel. I'm taking the online portion of this engineering case studies class. I'm recording this presentation in a hotel and I apologize I don't have the slides behind me. I will be referring to the slide titles as I move along through the presentation. And a little bit about myself before I get started. I previously was the safety engineer for a former company I worked with in Buffalo, and my job mainly consisted of dealing with accident investigations and developing new reports to help prevent a similar accident from occurring again within the organization. And I learned a lot during that role about accident reporting and investigations, and I learned that they're all reactive due to a gap or failure not being addressed, and I was very motivated to learn from this section and see the systematic reporting process that NTBS has adapted. It was a bit different from what I was used to, and reading through the accident reports put a time frame in perspective for follow-up and recommendations. A lot of the times this area is rushed, and it's unfortunate because it's the most critical aspect in preventing the same failure from occurring again, which was discussed in last class. My partner and I selected an aviation failure accident, and the report title is Uncontained Engine Failure and Subsequent Fire. And the failure occurred on an American Airlines flight in Chicago on the runway before takeoff. And you can see from figure 7, if you're following along, the airplane was brought into examination after the accident. And this picture is from the right wing of the aircraft and revealed 2 distinct penetration holes. And I'll explain more about how that happened, which ultimately led to the fire and evacuation. So what led to this failure? Figure 5 is a picture from the post-accident engine and the observations of the disc, which was heavily discussed throughout the report. It was recovered from the scene and it was broken into 4 different fragments, and as you can see, they're labeled A through D, and about 96% of that disc is there and being examined. The report mentions that the disc was manufactured at General Electric aircraft engines, and a root cause was done from the failure, and it was believed to be due to the fatigue crack from a dirty spot located near the bore region. And the root cause analysis traced back to the manufacturer to understand more about the inspection process and if it was able to be caught by the human eye before being sent out and installed on the plane. Main engine fuel failure. So figure 10 shows the white spot which contributed to the fracture of the disc, which eventually caused the penetration to the main fuel feed line and caused the engine to catch on fire. The engine failure was a direct result from the cracked disc. Fire detection failure. So after all the mechanical problems caused by the disc, after the fire started, it was found that the fire alarm detection failed, which delayed the evacuation process off the airplane. And root cause investigation proceeded after, and it revealed that there was a failure for a sound alarm to signal and activate, which delayed the whole event, and unfortunately someone ended up being seriously injured because of this. Evacuation procedure failure. So when the fire started and the evacuation process began, the flight attendants began signaling to the passengers to exit the aircraft while it was stopped on the runway, shown by the picture below. And the report specified that a serious injury occurred, and it was resulted from a passenger evacuating from the left overwing exit while the engine was still operating, which shouldn't have happened. And the reasoning behind this was due to the lack of communication and not having a proper checklist procedure for the specific Boeing aircraft that was being operated. And the picture used in this slide was from one of the passengers that evacuated the plane. It was a video recording, and it really spoke a lot, put a lot into perspective about this devastation caused by the accident. Causal chain. So this identifies the main factors that were looked at and contributed to the failures. 2 items were mentioned that were later considered to not have a significant impact, and 3 and 4 dealt with the plane mechanics contributing to the failure, and the majority of the other items, 6, 7, 8, and 9, were personnel related and boils down to training related and procedural related. Probable cause. This slide summarizes the main failures that have been discussed and the domino effect of failures, starting with the disk anomaly at the manufacturer all the way to the delayed evacuation shutdown response when the fire started. And the report suggests that mechanical failures and the disk was the direct cause for the accident and preceding events which took place after the failure, and also the personnel failures due to the gaps and lack of training procedures offered to the flight crew for that specific air carrier, that Boeing. Published report. The report was published on NTSB 3 months after the accident occurred, and recommendations were issued a little over a year after that. And one thing to mention also is the recommendations that were made also referenced similar types of failures that occurred in different aircrafts as well. And so a lot of action items that are being worked on with the disc manufacturer were being worked on even after that, or even before that failure occurred. Recommendations, slide 10. The recommendations report consisted of 3 main sections which made proposals directly to the FAA, Boeing Company, and American Airlines. All 3 targeted the procedures as an opportunity for improvement, and the FAA had the only engineering recommendations to improve the types of material and alloy used in making the disc, and also expanded on the inspection procedure process for assembly. Adoption metric. There were a series of adoption metrics discussed throughout the report to improve engine design. The recommendations report reference similar types of failures like I mentioned, slide ahead, and they all have occurred in the past, and there has been development of new inspection procedures along with new materials to be required when making the aircraft engines. So fortunately, there were no fatalities that resulted from this accident, which was great. Unfortunately, there was a serious injury, which could have been avoided if people were properly trained on that aircraft. And moving forward, the recommendations that were proposed will help avoid a similar failure from occurring again. So this is the end of this report, and I'll be conferencing in during class time tomorrow. Feel free to forward me any questions or my partner any questions you have on this report. And I look forward to listening to the other presentations in class and learning about the various types of transportation failures everyone else worked on. Thank you for listening.